Hi, welcome to GEETHA'S classes. Today we are going to see about the course Discrete Mathematics ME 8351. Under this, the topic is Inference Theory. So in continuation of the previous video in Unit 1 Logics and Proofs, today we are going to see Inference Theory. Come on, let us move on to the topic. Unit 1 Logics and Proofs. So under this, we are going to see Inference Theory. So for this inference theory, we need few rules. So we are going to see that rule first. One is universal specification. What does mean by universal? Universal means the whole world. That is, you have to write for all x. Okay. So for universal specification, we are writing for all x p of x. So we are writing this for all x p of x by p of c, okay, for some c, right? So we are replacing for all x p of x by p of c. That is universal specification. So universal thing we are specifying to some particular c, okay, right? So now existential specification. Existential means, so for example in a class, so class is universal specification, universal. We are choosing one particular student from that class. That is existential. Okay, that existential means there exist. Okay, so here there exists x p of x can be written as p of c, right, for particular c. Okay, now universal generalization, third one is universal generalization, UG. Okay, so here the reverse process of universal specification, you have to write it in generalization. Okay, p of c can be written as for all x p of x. Okay, p of c for arbitrary c can be written as for all x p of x. That is universal generalization. Next one is existential generalization. Okay, that is EG. So the opposite, the reverse process of existential specification. P of C can be written as there exists x P of x. Okay, so that is your existential generalization. P of C for some C can be written as there exists x P of x. Okay, so again three more rules are there. Universal modus ponens. Already we have discussed modus ponens in rules of inference. Okay, universal means for all x. So you are writing for all x p of x implies q of x. You are adding this with p of a. P of x and p of a getting cancelled. You are getting the positive value of q of x. Okay, so for that q of x we are writing q of a. Okay, in modus ponens what we have write? P implies Q and P. So PP get cancelled. You are writing answer as Q. Okay, that is normal modus ponens. Here universal modus ponens means you are writing in terms of X. Okay, for all X. P of X implies Q of X. Adding with P of A, your answer is Q of A. Okay, that is universal modus ponens. Now, universal modus tollens. Tollens means negative, right? So, the same thing we are adding with for all x, p of x implies q of x. You are adding with negation q of a. Okay. So, q of a and q of x get cancelled. Your answer is negation p of a, right? So, your answer is negation p of a. That is universal modus tollens. Next one is universal transitivity. So already you know transitivity. A implies B, B implies C, that implies A implies C. Okay, that is transitivity. Universal means you are writing in terms of X. For all X, P of X implies Q of X. For all X, Q of X implies R of X. We can say for all X, P of X implies R of X. Okay, that is universal transitivity. Okay, next one, we are moving into the problem number 1. Prove that there exists x m of x follows logically from the premises for all x h of x implies m of x, and there exists x h of x. Okay, so you read the question carefully. The answer is given, the conclusion is given in the problem. There exists x m of x is the conclusion. So you have to arrive this conclusion using the given premises. For all x, h of x implies m of x and there exists x h of x. Okay, you can use any rule so far we have discussed. Okay, now we are moving into the question solution. So first we are using the given statement. Okay, so given premise we are introducing there exists x h of x. So this is our given premise. So given premise means we are going to write rule P, right? Now, so this there exists x h of x can be written as h of a. This is by exist. Exist means e, right? Rule es, right? Existential specification. Okay. So we are using step number 1, comma yes, right? So by using rule es, we are writing h of a. Now again we are inserting the given premise. For all x, h of x implies m of x. So that is rule P. So we are writing the given premise. So rule P, right? What is the next step of this? Instead of x, we are writing some particular a. Okay, so h of a implies m of a. So here by using the rule, here for all, so universal specification, right? So the next step is by using universal specification, that is using step number 3 and us, we are writing h of a implies m of a. Okay. Now you combined 2 comma 4, step 2 and step 4. What is step 2? So we have taken h of a, right? That is in the step 2. So h of a and h of a get cancelled. Your answer is m of a. That is modus ponens. We are using, this is not universal modus ponens, normal modus ponens. Okay. So we are just cancelling h of a, and we are writing m of a. Okay. Now, so m of a can be written as our final conclusion. There exists x m of x. Okay. So we are replacing m of a by there exists x m of x. So the opposite of universal generalization. So here we are writing existential generalization. Okay. The opposite of existential specification. Right. So here m of a can be written as there exists x m of x. So this is nothing but existential generalization. So we are using the fifth step and we are using EG, right? So we have arrived at our conclusion. This is our final answer. Okay. So your answer is in the question itself. So you have to identify using the premises, given premises, you have to identify that conclusion. You have to arrive at that conclusion. Okay. So that's all for this problem. So we have arrived at the conclusion. Okay. Thank you. If you like my channel, please subscribe. Okay.